Let us study chemistry together with CBSE Chemistry tips and tricks.
In this session, we will be discussing about the most important 15 unnoticed questions from the lesson Chemical Kinetics. For a reaction A2 plus B2 gives 2AB, the figure shows the path of the reaction in absence and presence of a catalyst. What will be the energy of activation for forward and backward reaction in presence of a catalyst, and enthalpy change delta H for the reaction? The dotted curve is the path of reaction in presence of catalyst. See here you can see without catalyst this is the path. Okay, and with the catalyst this is the path, right? See, in this particular question they ask activation energy for backward and forward reaction in the presence of catalyst. But see, I am explaining both cases, okay, without catalyst and with catalyst. First I am explaining without catalyst. Okay, see, check. See, without catalyst this is the path of reaction. See, what is the initial energy of reactant? 60. What is the peak value? 80. So 80 minus 60, peak value minus initial energy of the reactant will give you what? Activation energy. So 20. Clear, right? 20. See, don't write 80 as answer, okay? That is wrong. What is the answer? Peak value minus initial energy of the reactant. Now, for the backward reaction, see, product become reactant, right? So this will be the reactant and this will be the product for the backward reaction. So what is the activation energy? So what is the initial energy of this one? Now this is the reactant, right? For backward reaction, this is the reactant. So what is the initial energy? 50. What is the peak value? 80. So peak value minus energy of the reactant for the backward reaction. So 80 minus 50, you will get what? 30. Clear, right? Now what is the enthalpy change? Enthalpy change means energy of the product minus energy of the reactant. Okay, enthalpy change for the forward reaction is what? Enthalpy of the product minus enthalpy of the reactant. So what is that? 50 minus 60. So what is that? 50 minus 60 gives minus 10. Clear, right? Now with the catalyst. With the catalyst means this is the path. Okay, right? This is the path. Okay, right? Now with the catalyst, what is the activation energy for forward reaction? See, initial energy is 60. Peak value is 70. 70 minus 60 will give you what? 10. Clear, right? 10. Now for backward reaction. Backward reaction means this is the backward reaction, correct, right? Okay, so for backward reaction, you know, product will be the reactant. Okay, so what is the activation energy? Peak value minus initial energy. So 70 minus 50. For backward reaction, activation energy is what? 70 minus 50, peak value minus initial value. What is that? 20. Now you know that catalyst have nothing to do with enthalpy change, right? So what is enthalpy change? See, energy of the product minus energy of the reactant. Okay, energy of the product is again what? 50 minus 60, you will get what? Minus 10. Catalyst have nothing to do with enthalpy change, Gibbs free energy change. Okay, right? That's it. The following data were obtained during the first order thermal decomposition of N2O5 at a constant volume. See, they have given the chemical equation. You can see this. And they have given pressure when time t is equal to 0, which means initial situation. And pressure, total pressure when time t is equal to 100 seconds. See, for pressure based question, say I'm going to say very important hint. If the reaction is of this type, A gives a single reactant with the stoichiometric coefficient 1 undergo reaction, decomposition reaction to give B plus C. Now if you check the coefficient of A, B and C is 1, right? Okay, then see the equation for rate constant K is equal to 2.303 by T log initial pressure by 2P0, 2 times initial pressure minus PT. PT is the total pressure at T time. Okay, this equation you can use only when the coefficient of A, B and C are 1. For example, in this question, see the coefficient is 2, 2 and 1. You cannot use this equation. Understand? In such cases, which equation we have to use? For any other type, you can go for this. 2.303 by T log initial pressure by present pressure. Okay. See, this is standard. The second one is standard. You can use anywhere. Okay, you can use anywhere. And first one only when the coefficient of A, B and C is 1. Got it right? Now for this particular question, we are going to use the second equation, which is standard. Okay, let us see. So our task is to find what? K, rate constant, right? Okay, so for that purpose, write the equation. 2N2O5 gives 2NO2 plus O2. Initially, only N2O5 will be there, right? Only reactant will be there on the starting of the reaction. So initial situation when time t is equal to 0, only N2O5 is there. So we can say it as PO. PO value is given in the question, right? What is PO? Initial pressure. Pressure when the reaction starts. What is that? 0.5. Now, as the reaction proceeds, what happened? The concentration of the reactant start decreasing. The pressure due to reactant start decreasing. Correct, right? Now, what is the stoichiometric relation? 2N2O5 undergo reduction to give 2NO2 and 1O2. Correct, right? As the reaction proceeds, what happened? The concentration of the reactant decreases. The pressure due to reactant also decreases. Assume that reduction is 2x. Okay. Now, as per the ratio, as per the stoichiometric ratio, what should be the increase of pressure due to the product? It will be 2x and x. Correct, right? See here, you can see NO2 and O2 are forming. Okay. So pressure, this much of increase of pressure will be there. And for N2O5, this much of decrease of pressure will be there. Initially, PO pressure is there. N2O5 undergo reaction. So there is a decrease of concentration of N2O5. So what will happen? There is a decrease of pressure of N2O5. How much? 2x. And there is an increase of pressure of NO2 and O2. Okay, right? Now, what is the present pressure? See, present pressure. See, when time t is equal to t. See, for N2O5, initial pressure is P0 minus 2x, right? There is a reduction. For NO2 and O2, from 0, it becomes 2x and x. Clear? Now, what is the total pressure due to all gases in the chamber now? See, it will be equal to the pressure of N2O5 plus pressure of NO2 plus pressure of oxygen, right? On adding, we will get what? P0 plus x, correct? So what is x? See, we got Pt is equal to P0 plus x, right? So what is x? X is equal to Pt minus P0 or P0. Okay, right? Now, what was our equation? Our equation was K is equal to 2.303 by T log P0, initial pressure of the reactant. This one, right? P0 by present pressure of the reactant. That is very important, okay? P0 minus 2x. Clear? You remember, right? We start the numerical with this hint. See, what was the equation? K is equal to 2.303 by T log initial pressure of the reactant by present pressure of the reactant. What is the present pressure? You can see, right? P0 minus 2x. P0 minus 2x. Correct, right? Okay, fine. Now we can substitute the x. It will be like 2.303 by T log P0 by P0 minus 2 into Pt minus P0. Okay. So on calculating, we will get 2.303 by T log P naught by, see, on calculating what you will get, you will be getting like 3 P naught minus 2 PT, correct? Now it is just a matter of substitution. 2.303 by T, what is T? 100 log, what is P naught? 0.5 by 3 P naught, 3 into P naught is 0.5 minus 2 into, what is PT? 0.512. Pressure at T time, what is T time here? 100. Substitute, you will get the answer. So what is that? K is equal to 2.303 by 100 log, what is P naught? 0.5 by 3 into 0.5 minus 2 into, what is PT? 0.512. Okay. On calculating, you will get like this. Now 2.303 by 100 log, see, on dividing you will be getting like 1.05. Okay, see, log value you have to find from logbook, or in exam they will give the value. So log 1.05 is 0.0212. Okay, see, it's a case of just a matter of multiplication and division. You will be getting like 4.88 into 10 raised to minus 4, as it is a first order reaction, second raised to minus 1. Clear, right? Okay. The activation energy of a reaction is 0. Will the rate constant of the reaction depend upon temperature? Give reason. See, here question is connected with activation energy and temperature. So you can directly go for Arrhenius equation. Okay. So what is equation? K is equal to A E raised to minus EA by RT. Now as per the question, what is activation energy? Activation energy is equal to 0. So what is the equation? K is equal to A E raised to minus 0 by RT. So it becomes what? K is equal to A, right? Or you can say like K is equal to A E raised to 0, which means K is equal to A, right? So rate constant is equal to Arrhenius constant. So you can say rate constant K is independent of what? Temperature, right? Consider the reaction A gives B. The concentration of both the reactant and the product varies exponentially with time, which means the concentration of the reactant decreases exponentially, right? And concentration of the product definitely increases exponentially. Got it, right? Which of the following figure correctly describe the change in concentration of reactant and product with time? You understand, right? Both varies exponentially with time. Now we know what happened to the reactant. Reactant will be decreasing and variation is exponentially. So decreasing exponentially, like this, right? Exponential decrease. And regarding B is the product increases exponentially. As per the question, varies exponentially, but as it is product, we know that it increases, right? So increases exponentially. So which is our graph? B. Clear, right? Option B will be our right answer. Got it, right? For a reaction A gives B, the following graph is plotted. Then which is incorrect? See, if you check first two options, it is about activation energy, right? Now how to find activation energy? Subtract the energy of reactant from peak value. So you will get what? Activation energy. So here what is peak value? Peak value is 100 minus energy of reactant. What is that? 60. You will get what? 40. That will be your activation energy. So this is correct, this is false. Now we can check, okay, we can check enthalpy of reaction. See, enthalpy of reaction means enthalpy of product minus enthalpy of reactant. So enthalpy of product is what? It is 20. 20 minus reactant is 60. 20 minus 60 is what? Minus 40. And remember, Remember, this is exothermic reaction, very important, okay? If the energy of the product is lesser than energy of reactant is 60, product is 20. If the energy of the product is lesser than energy of reactant, then it is exothermic reaction. Exothermic. Anyhow, this is correct. Now, what is the last one? Threshold energy. See, threshold energy, you can take the peak value. Okay, peak value. What is that? 100. So that is also correct. Peak value is correct. Enthalpy of reaction is correct. Second option is correct. So first one is wrong. Good question. Okay, it's a good question. The decomposition of dimethyl ether is a fractional order reaction. The rate of reaction is given by rate is equal to K into, see, pressure of, it is like K into pressure of CH3OCH3. It is like that, okay? Instead of concentration, pressure is given, raised to 3/2. Okay, so rate is equal to K, pressure of CH3OCH3 raised to 3/2. If the pressure is measured in bar and time in minute, then what will be the unit of rate and rate constant? See, normally you know what is the unit of rate. What is that? Mole, liter inverse, second inverse. See here, instead of mole per liter, we are using pressure. And what is the unit of pressure? Bar. Okay. Now, instead of second, what we have to use as per the question, it is minute. So, bar minute inverse. Instead of mole per liter, see, we are using the unit of pressure. Okay. So, that's why bar. See, sometimes they will say ATM or sometimes they will say Pascal. So, instead of bar, you have to use like that. Now, instead of second, they asked to use what? Minute. So, minute inverse. So, we got the unit of rate. Bar minute inverse. Okay, right? Now, we have to find what? The unit of K. It's very easy. We can do that. So, what is that? K is equal to rate by pressure of CH3COCH3 whole raised to 3/2. That is the equation, right? Okay, now unit of K. Unit of K. Okay, we can try. What is the unit of rate? Unit of rate is bar minute inverse by. What is unit of pressure? Pressure is bar whole raised to, see here you have 3/2, right? 3/2. So what you will get? Bar 1 minus 3/2 minute inverse. So what is our answer? Bar 1 minus 3/2 is what? Minus 1/2 minute raised to minus 1. Clear, right? So what is our answer? Check. Option B, right? The unit of rate is bar minute inverse and unit of rate constant is bar raised to minus half, minute raised to minus 1. Clear, right? Okay. Define Boltzmann factor. Boltzmann factor represent the fraction of molecules in a system that have energy equal to or greater than the activation energy required for a reaction to occur. In simplified terms, we can say that Boltzmann factor represent the fraction of molecules which are capable of reaction. Now, see the equation. You can see the equation like this. Ne, number of molecules having energy equal or greater than activation energy. Okay, that is Ne. By total number of molecules. So it's a fraction, right? Number of molecules having energy equal or greater than activation energy by total number of molecules. Okay, and that fraction is equal to E raised to minus Ea by RT. Correct, right? And you remember, this factor we can see in the Arrhenius equation also. Okay, so this factor will give you the fraction of molecules which is equal or greater than the activation energy. So sometimes in exam they will give Arrhenius equation. K is equal to A e raised to minus EA by RT. And they will ask what this is representing. This is representing the fraction of molecules in a system that have energy equal or greater than the activation energy. That is what you are supposed to write, okay? And that is exactly what Boltzmann factor. Clear, right? Now, when temperature increases, what happens? This factor increases. So K also increases. Clear, right? When temperature increases, see the amount or fraction of molecules having energy greater than threshold energy definitely increases. This value will increase. So K also increases. Now for your understanding, we can assume a scenario EA equal to 0. So what will happen? It will be like K is equal to A e raised to 0, which means what? K is equal to A. What is the meaning of that? It means, see, now it is A into 1, right? A into 1. What is the meaning of that? See, all the collisions are now leading to a reaction. All the collisions are now leading to a reaction. Why? Because now activation energy is 0. Okay, so each and every collision will lead to a reaction because there is no need of an activation complex formation for the reaction to happen. If a collision happens, as the activation energy is 0, it will directly lead to a reaction. Okay, but it is not practically possible. Okay. Also, we can say in this scenario, see the rate constant is independent of temperature. Correct, right? Explain Maxwell-Boltzmann distribution curve in detail. We know all the gas molecules in a reaction vessel are not moving at the same speed, right? Some are slow, some are super fast, and some are somewhere in between, right? See, the Maxwell-Boltzmann distribution curve help us to understand how many molecules have different amount of kinetic energy. See, for that purpose, we can plot a graph in such a way that on x-axis we have kinetic energy and on y-axis we have fraction of molecules. Okay, for example, see, assume we have some 30% of molecules having 50 joule of energy, 20% of molecule having 100 joule of energy, like that. Okay, so we are going to plot a graph between that. Now, look at the shape of the curve. You can see it rises, reaches a peak, and then falls, right? See, for understanding, you can check some values, okay? For example, 10 joule, 10%, like that. 30 joule, 35%. You can see, right? Just for understanding, I mark all those things. Actually, that is irrelevant, okay? Now listen. If you check the peak value, this point, right? 40% of the molecule is carrying how much energy? 35 joule. So 35 joule we call it as maximum probable kinetic energy. That is the kinetic energy carried by maximum fraction of molecule, 40% of molecules. Then you can see a point here, activation energy point, right? So after activation energy, you can see some fraction of molecules, right? So this is the fraction of molecules which have energy equal or greater than activation energy. Only these molecules can undergo what? Effective collision and thus undergo reaction. Clear, right? So area under this part, okay? This much fraction of molecules undergo effective collision or leads to reaction. Clear? Now, assume a scenario where we increase the temperature. What will happen to the energy of molecules when we increase temperature? Definitely it increases. For example, the molecules having 10 joule after increasing temperature become 25 joule. So what about the molecules having 20 joule? It become 40 joule. Like that. I am saying some values, okay? 30 joule it become 50 joule, 40 joule maybe it become 80 joule, 50 joule maybe become 100 joule, like that. So you can see an overall shift of molecules towards, overall shift of energy of molecules towards the right. Okay, So assume that we increase the temperature by 10 degrees Celsius. So what will happen? See, the graph will shift like this. The graph will shift like this. Okay. Now you can see more fraction of molecules crosses 50 joule, right? Clear, right? It's very clear. It is very evident from the graph, right? See, now you can see lot of more molecules start crossing the 50 joule. So what is the meaning of that? More and more effective collision will happen, which leads to increase of rate of reaction. Correct, right? Remember, the area under the curve must remain constant, okay, because it represents what? The total number of molecule, okay, or total fraction, which is 100%, which will never change. But as the energy of the molecules are increasing, you can see a shift of curve, okay, towards right, so that the fraction of molecule or area under the curve which have energy greater than 50 joule now increases. Okay, that is very clear, right? Which means more effective collision will happen, rate of reaction increases. So this is the graph you are supposed to study. You check what is there on the y-axis, what is there on the x-axis, and you can see two curve. First curve, right, that is for T temperature, and second one is for T plus 10 temperature. And remember this particular point, it is most probable kinetic energy. Okay, now you can see this is activation energy region, right? First case, see, this is the area under the curve. Now for T plus 10 temperature, you can see area almost become doubles. That point you keep in mind. When temperature increases by 10 degrees Celsius, see, the molecules under the curve almost doubles, which means rate of the reaction almost doubles when you increase the temperature by 10 degrees Celsius. Okay, that point you keep in mind. Explain the complete theory, but this is the notes. If you want the notes, you can check here, okay? You can see Boltzmann distribution curve. All the molecules of the reactant do not have the same energy. The number of molecules possessing very low kinetic energy is very less, and very high kinetic energy is also very less. Most of the molecule have average kinetic energy, right? Effect of the temperature on the curve. When temperature increases, the maxima of the curve is moving towards right, correct, to the higher energy region. Okay, and see, what is the reason? The kinetic energy is directly proportional to the temperature. As you increase temperature, the kinetic energy of the molecule is increasing, so the graph will shift towards right. Okay, right? Now, see, the peak of the curve is known as what? Most probable kinetic energy. That you keep in mind. Now, the area under the curve must remain constant. Okay, because it represents the number of molecules which will never change. Okay, now by using the curve, we can find the activation energy. And also you have to keep in mind what? When you increase the temperature from T to T plus 10, the area under the curve almost doubles. So these are the things you have to keep in mind, okay, when you deal with Maxwell-Boltzmann distribution curve. Also the graph also you have to keep in mind, the definition of maximum probable kinetic energy, all things you have to go through. The rate law is R is equal to K concentration of A into concentration of B raised to 3 by 2. Can the reaction be an elementary process? Why? Or explain. See, no. What is the reason? See, for an elementary reaction, order and molecularity will be same. Okay, now here what is the order? Order is equal to, see, power of A, that is 1, and power of B, that is 3 by 2. On adding, you will get what? 5 by 2. For an elementary reaction, molecularity and order must be same. What is the order here? 5 by 2. But we know molecularity will be a whole number. It can't be a fraction, right? Here you can see a fraction. So in this case, molecularity and order will not be same. If they are not same, then it does not represent an elementary reaction. Clear, right? Perfect. The decomposition reaction of ammonia gas on a platinum surface has a rate constant is equal to 2.5 into 10 raised to minus 4 mole liter inverse second inverse. What is the order of the reaction? See, it's a tricky question, but very easy. See, they have given the value of K. What is that? 2.5 into 10 raised to minus 4. Also, they have mentioned the unit mole liter inverse second inverse. See, the unit of rate constant is exactly same as that of unit of rate of reaction, which happens only for zero order reaction. Correct, right? For zero order reaction, we know the unit of rate and rate constant becomes same, and you can see that here. So which order? Zero order reaction. Also, as an example for zero order reaction, you can learn this reaction. Which reaction? Decomposition of ammonia. So ammonia undergo decomposition reaction to give N2 and H2 is an example for what? Is an example for zero order reaction. Okay, remember it. As an example, you can study this. Okay. The decomposition of a hydrocarbon follows the equation K is equal to 4.5 into 10 raised to 11 second inverse E raised to minus 28,000 Kelvin by temperature. See, we have to find the value of activation energy, EA. Okay, so directly you write Arrhenius equation and compare it. Okay, so K is equal to what? A E raised to minus EA by RT. Correct? See, this is the given equation and this is the Arrhenius equation. Just compare it. You will be getting the direct answer. So you can compare the powers of exponential function. So minus EA by RT is equal to minus 28000 Kelvin by temperature. Temperature you can cut. Minus you can cut. So what is that? EA is equal to 28000 Kelvin into R, right? Correct. Now what is R? 28000 Kelvin into R is what? 8.314. That is the value, right? Now what is the unit? Joule, Kelvin inverse, mole inverse. Now this Kelvin inverse and Kelvin get cancelled. Okay. So on calculating, what you will get? 232.790 joule per mole. Okay, and if you want kilojoule answer, divide this with 1000. So what you will get? 232.790 kilojoule per mole. Okay, right? Okay, that's it. The rate of a reaction doubles when its temperature changes from 300 Kelvin to 310 Kelvin. Activation energy of such a reaction will be, we have to find the activation energy. Okay, they have given the options. See, if you check this question, it is very clear that they have given two temperature, right? And they mentioned that the rate of the reaction doubles. Now, for a question regarding two temperature and activation energy, we have only one equation. Directly go for that equation. What is the equation? Equation is log K2 by K1 is equal to EA by 2.303 R into 1 by T1 minus 1 by T2, right? Remember one important thing, okay? See, due to temperature change, if anything happen to rate of reaction, the same change will happen for rate constant also. Keep that point in mind. See, if we increase temperature or if we decrease temperature, then assume something is happening to the rate. Same change will happen to the rate constant also. As per the question, what is the new rate? New rate is 2 times the original rate when you increase the temperature from 300 Kelvin to 310 Kelvin. So remember, the rate constant, the new rate constant will be equal to 2 times the initial rate constant. Hope you understand. So assume in the question, if they say rate of reaction triples, so K2 will be 3K1. Like that you have to understand. So it's easy. log, instead of K2 you can write 2K1 by K1 is equal to EA by 2.303 R into 1 by 300 minus 1 by 310. See, temperature must be in Kelvin scale. Sometimes in the question they give in Celsius. Okay, convert to Kelvin scale. Otherwise your answer will be wrong. So K1 cancel. Log 2 is what? 0.3010, right? Is equal to EA by 2.303. What is R? See, we need answer in kilojoule. So write 8.314 into 10 raised to minus 3. Otherwise you can put 8.314. Okay, you will get answer in joule. So then what? 310 minus 300 by 310 into 300, right? Now we have to solve this, right? So EA is equal to what? 0.301 into 2.303 into 8.314 into 10 raised to minus 3 into 31 into 3 is what? 93,000 by 10. Now it is your task. You have to substitute all these values and finally you will be getting like 53.6 kilojoule per mole. So this is our answer, okay? 53.6 kilojoule per mole. That is our final answer. Got it right? The plot of log K versus 1 pi temperature for a reaction has a slope equal to minus 4500 Kelvin. What is the activation energy of the reaction? A question connecting activation energy and temperature, right? So you have to start with what? Arrhenius equation. Start with Arrhenius equation. K is equal to A e raised to minus EA by RT. Take log on both sides, you will get what? Log K is equal to log A e raised to minus EA by RT. Correct, right? Now, see on RHS part, use the rule of log. Log AB is what? Log AB is log A plus log B. Correct, right? EA by RT. See, this is A and this is B. So log AB is what? Log A plus log B. Okay, now log K is equal to log A. See, log E raised to X is X, okay? That is another rule you must know. So what is that? Minus EA by RT. Clear? Log E raised to minus EA by RT become minus EA by RT. This rule, okay? This rule we use. Okay, now we can write it properly. Log K is equal to log A minus EA by R into 1 by T. Correct? Now check. You can see this is comparable with equation of straight line. Y is equal to, see, X, M and C. On x-axis you have 1 by temperature. On y-axis you have log K. Correct, right? Now, what is the question? If we plot a graph between log K as y-axis and 1 by T as x-axis, then the slope is equal to what? Minus 4500 Kelvin. So here what is the slope? Minus EA by R, right? And that is equal to what? Minus 4500. Clear, right? See, very easy. Minus EA by R is the slope. Okay, as per the equation. As per the question, what is that? Minus 4500. Clear? Okay, right? 4500 Kelvin. Correct, right? Now, minus get cancelled. So what is EA? EA is equal to 4500 into 8.314. See, on multiplying, we will get 37413 joule. Okay. Now, if you want to represent the answer, sometimes if it is an objective question, they will give the answer in kilojoule. Okay, kilojoule. At that time, what you have to write? EA is equal to, divide this with 1000. So what is that? 37.413. See, this is joule per mole. Other one is kilojoule per mole. Okay, right? Okay. If answer is in kilojoule, divide the answer with 1000. Okay, 1000. That's it. For a reaction, 2H2O2 gives 2H2O plus O2. The proposed mechanism is as given below. You can see two steps, right? First step is slow one and then a fast step, right? First question is write the rate law for the reaction, then overall order, then which one is rate determining step. Okay, here we have a complex reaction, correct, right? Which is split into two elementary reactions. And in the question it is given that first step is slowest step. From the slowest step, we can write the rate law, correct, right? Remember, these two steps are elementary reactions, okay? Now for elementary reaction, you know you can take the stoichiometric coefficient as power. Okay, and you have to write the rate law from the slowest step. So R is equal to K, concentration of H2O2 raised to 1, I minus raised to 1. Correct, right? I minus raised to 1. Okay. Now, what is the overall order? Just add the powers, right? 1 plus 1. So, what is that? 2. Correct? Out of step 1 and 2, which one is the rate determining step? Of course, it is which one? The slowest step is the rate determining step. Clear, right? Okay. Remember, see, if we have a complex reaction, what we will do? We will split into elementary steps. That will be given in the question. Okay. Now they will say one of them is slowest step, like that. So you have to identify that. From that you can write the rate law. And from rate law you can write the order, like that, like that. Hope you understand. See, it's comparatively easy question, but repeatedly asked question. Okay. Explain collision theorem. See, according to collision theory, effective collisions are those in which reacting molecules collide with. What? There are two criteria for a collision to be effective. Which are they? First one, sufficient kinetic energy, which means equal or greater than the threshold energy, plus proper orientation. See, these two criteria must be satisfied. Then only a collision must be effective and leads to a reaction. Only this collision result in the formation of product. Clear? According to collision theory, the equation for rate is modified like this. Rate is equal to P. P is steric factor. ZAB is collision frequency. Then E raised to minus EA by RT. You know this, right? Boltzmann factor. Right? Okay, that's it. Okay.